All right. So today, right now, right here, right now, I would like to make a little video going over the find blank and possibly find tile functions because they're very, very similar. And to be honest, I would say that they're not only similar, but they're pretty straightforward if you understand what's been done so far. And I think not everybody fully understands. So let's try to maybe comment this code and maybe bring some clarity to what's happening along the way. This is the max value in the board. The max or initial value placed in the board, right? Because if it's a 4x4 board, it's gonna, the first value, your max value is gonna be 15 because we have a space. So that's why it's n times n minus 1 for n reach n. So this is going to iterate 4 times, right? We're going to iterate or iterate a loop to iterate n times. And this is going to add, right? Add or append n number of empty lists in board, which is itself up here, right? So here we are initializing initializes an empty list, right? Wow. So this is the max or initial value placed in the board. So I have a loop to iterate n times. While I'm iterating n times, I am appending n number of empty lists in the board. Okay, so that's what I got. So at that point, you know, in that code, I'm sitting there with that list of empty lists, right? And so here, I'm going to, you know, again, iterate n number of times. And then I'm going to iterate n number of times again. And this is where it might get a little tricky. So the reason why I'm doing that is because I want to deal with the kind of the rows and columns situation in the board. So let's see what I've got so far. So far I have num rows equals 4. I have make board, I have display board. Okay, so this is really the only code that's sort of active or live right now. So let's run this thing and see what we get. And sure enough, oh, I didn't finish writing this in the other class. Oh, I didn't finish writing it. Okay, I didn't finish writing it. Maybe we'll finish writing together. But just so you can see real quick, the idea is, and so maybe better yet, I look at board itself. So here's board itself, right? And you see it's the overall list, and then it has lists inside of it, which each has elements inside of it. And so what I'm talking about here, you know, for that, let's talk about populating this first list. Let's talk about populating that first list, right? So the first time I go through this double for loop construction, right, J would have a value of 0, right, when it hits this inner loop. So when it hits this inner loop, J is 0, and so you're saying board index 0 dot append value, right? Well, the very first time that hits, it's going to put the 15 in there, right? It's putting the 15 in that first, first spot of that first list. It's actually appending onto the empty list, right? Then we make value be 1 less, so value will be 14. I'm not going to go to this outer loop, this J loop. I'm coming back into the K loop. So I'm going to really finish this entire loop before I get to come back up to the J loop, right? And so what am I talking about? I don't know. And so, yeah, so J is still 0, right? And I'm going to append another value on there. So that'll be 14, becomes 13, staying in the K loop. again, j is 0, I append 12, or whatever we're at, 15, 14, 13, 12. Basically, it's going to happen 4 times, right? N number of times. I'm going to append something on there. And then when I'm done, with this loop n number of times, I'm going to come back to this outer loop, and what's j going to be? J is going to be 1. And so when I put 1 in there, what that does is it moves me to this middle list, right? And when it moves me to that middle list is empty, right? And then it appends 11, and it appends 10, it appends 9, it appends 8. And again, moves back up there, j becomes 2. This is an empty list. And then it appends those values. So that's how that works, right? And so that kind of builds the list. And so the board is actually perfect. Display board is not so great right now. And I talked about this in class multiple times, but I don't. People aren't quite getting it, I suppose. But one of the things that you might be really helpful is to understand how this works. Like, let's just look at the values themselves, like the values of I and j generated by this kind of double for loop. And you got 0, 0, 0, 1, 0, 2, 0, 3. And then take a look at this. Take a look at this. Take a look at this board, right? And do you see how this is like the 0, 0 location, and the 0, 1 location, and the 0, 2 location, and the 0, 3 location? This is the 1, 0 location, the 1, 1 location, the 1, 2 location, the 1, 3 location, etc., etc., etc. So this double for loop sort of beautifully, naturally, if you will, is going to step through this two-dimensional array. It's going to step right through it from the top left corner. It's going to run across, and it's going to keep stepping through like this. Okay, so that's an important thing to understand, I think. Okay, let's take a quick look at display board. So display board here, I was kind of changing it just to show people how it worked, and then basically got kind of this point where we got everything printing out, but we didn't like the way it looked, and so ultimately we had to put some if statements in there. Really, probably the first if statement is that, if board index I, index j happens to be 0, that's when I want to print out sort of the empty space, if you will. Okay, and then next, what if it's a single digit value? So what if it's less than 10? Then I want to print out, I really want to get a space in front of it. So one way to do that is to have a string and then a comma, because the comma is going to sort of add that space. So I have nothing in my string, but when I put a comma, I put space. There's other ways you could do this. And then I'm going to put my value, but I'm just trying to keep it all in terms of integers rather than typecasting. How do you like that? How do you like that? Otherwise, we got a two-dimensional value, and I could just print out the value. So now I kind of like the way that looks. And I run it, and I got a nice looking board. Like, that's kind of what we want. And this also kind of illustrates the row column nature of things. Again, 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. And then that double for loop kind of gets us exactly what we want. So let's come back up here and think about writing find blank, right? By the way, board, the variable board can be accessed in any of these functions. So, whatever. So here's what we got to do. We got to, let's talk about what we're going to do to accomplish this idea of finding the blank tile. First of all, there is no blank tile in board, right? At least the way I've kind of created my deal. There is no blank tile. Board has a value of 0, which when we write display board, the value of 0 gets represented with a blank spot. But there is no blank tile per se. So what we're really looking for is that location where 0 is in the board, right? So what I gotta do? Like in simple language, in simple words, I have to iterate through the board looking for 0, right? We also talked in class, we talked about this idea of a tuple. Tuple is just like a list. It's something that can hold more than one value, has parentheses instead of brackets. And I want to return the row column location of the blank spot, which is a 0. By the way, row column location. This is the row. This is the column. This is the row. This is the column. So if you want to, when we're doing this work up here, we could really think of J, representing the rows, and better yet, so it's not really the letter itself, it's the position in the indexing, right? So in this case, I represents the rows, and J represents the columns. Up above here, J actually represents the rows. When I say it's not the letter, it's the position. So what I mean is the first index, like that first thing is what's representing the rows. The second thing is what's representing the elements in the rows or the columns. So yeah. So first thing is rows, second thing is columns. Again, if you don't understand that, yeah, try to draw it out, step through it, ask questions. I don't know. I don't know what to say. So where are we at? So if you understand that, then our job is to sort of iterate through this board, looking for the 0, right? So if you really understand that, you should have a pretty good idea about how to go about this. And so first of all, we want to kind of set ourselves up to do the iteration, which would be the double for loop. And you may be like, well, why the double for loop? Well, we just talked about how the double for loop is going to give us every single location in the list. It's kind of how we displayed the board, as we iterated through every single value in the board and then printed it out, basically. And so what I'm looking for is so I believe this works. I believe you can just write like this, but let's write like this just to be safe. A little tuple. And that's it. Like if board ij is equal to 0, I is the row and j is the column. So it's as good as that's as good as it gets. It's as good as it gets. I mean, if you really want to be like a little more descriptive in terms of your variable definition, and this might be kind of a cool way to do it, is you could say for row in range j, for column in range n, you could say for board index row column return row column. I mean, that might be even more readable. Well, I mean, that is no doubt more readable, right? So how do we know if this works? I don't know. I don't know how we know if this works. We could take this little bit of code, which is inside the while loop we got sitting down there, and put that there and say blank equals find blank, right? And we could run this thing and ask ourselves, well, what would we expect the value of blank to be after running this code the first time? And let's go ahead and run this thing, and we could talk about it, but find blank is not defined. I see. The functions have to come before the calls to the functions in Python. Not true in all languages. But, okay. So boom. Now let's run this thing, and we get this, right? So let's take a look at the board. Where would we expect? Blank to be representing right now, and I think you would want to say it's in the 0, 1, 2, 3 row and the 0, 1, 2, 3 column. So let's check it out. Sure enough, there it is. Awesome. So is that it? Does it work? I mean, well, I don't know. I'd want to try some more things. Well, how can we do that? Well, let's see what board is. Here's board. I'm gonna go ahead and grab this thing. I could do this all in the shell, but I just want to do it here so you guys can kind of appreciate what's happening. So here's what I'm gonna do. Here's what I'm gonna do. I'm gonna say to myself, you know what? I'm pretty confident that this other code kind of works as I expect it to work, right? So what I'm gonna do is I'm gonna kind of overwrite this stuff and just give myself a board that I can manipulate, right? So I'm just going to say, hey, forget building the board. I'm just going to make my own board, like the great Carrie Oshiro from Washington Intermediate School. Carrie was like the Scott Baio, Ralph Macchio of 7th grade Washington Intermediate School. All the girls loved him. It was super cool. We were sitting in class one day, and the teacher gave us a piece of paper with no holes for your binder. And I didn't know what to do and how to put it in my 3-ring binder. And I looked at Carrie, and his paper was already in there. And I said, Carrie, how'd you get the paper in there? And he looked at me like really tough, and he said, I made my own holes. Yeah! We make our own board, right? And we don't need pre-made boards or whatever. We make our own, right? So when we run it like this, let's take a look. What would we expect board to give us back? Well, how about 1, 2? What do you guys think about 1, 2? I would think blank should be 1, 2 when I see the 0 sitting in that position there. And instead, it's something crazy. Why am I getting something crazy? I think I hit something nuts. Well, there we go. 1, 2. Okay, is that good enough? I mean, are you guys happy with that? Do you guys believe me? How about here? Let's try this. I'll put 0 there. What should that be? 2, 2. 22, I guess. I don't know. There it is. Boom. Looks good. And the logic looks good, so I feel pretty good about it. I feel pretty confident about it. I would say, and just showing you, like, this is just sort of a way to test things. I would, kind of get rid of it and get back to it. So next thing would be, hey, if you understand how that works, I think finding tile should be pretty straightforward. I mean, it's not exactly the same thing, but it's pretty close. Pretty close. So see if you guys can write that one on your own. And if you have any questions, please come into tutorial tomorrow. All right, good luck.